Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome to the Pytorch tutorial series. Today's video is about recurrent neural network. The name suggests that there is something that is recurring. So what is recurring in a recurrent neural network? So you might have noticed in the previous videos about convolutional neural network that convolutional neural network help you learn the features that are spatial, as in that are placed in a space. For instance, let's say if you have an image of an object, you can learn the spatial features such as the edges, the curves, the colors, and you can learn to identify the object using a multi-layer perceptron or a simple neural network at the last stage of the CNN. On the other hand, a recurrent neural network learns the features over time instead of space. We call it temporal feature learning, which means if you have a data that changes over time can be learned using recurrent neural network, but we can also identify some images using recurrent neural network, which I will show in the upcoming videos. But for now, just understand that RNN is temporal feature learning and CNN is spatial feature learning. To implement recurrent neural network in Pytorch, you need to import torch, torch.nn, torch.nn.functional in case you need it, and we are also importing numpy just in case we have to manipulate some numerical data. So let's see how it looks like. You might have noticed by now that each box says RNN and it has a time with it. So this box says t-1, this box says t, and this box says t+1. What it represents is this is the state at time t-1, this is state at t, and this is state at t+1. The green arrows are inputs, the red arrows are outputs, and there is a blue arrow that goes into the next RNN block. So what's happening here is each RNN block has its inputs, and each of the blocks give us some outputs, and there is also an output that goes into the next recurrent neural network block. And finally, we have the state output that we desire. So to explain it more clearly, we can look at this image. So this is folded image. When we unfold it, it looks like this. There is a time instant, let's say h at time instance 0, which has some output that has moved on to some time instance, and finally it reaches t-1, and from t-2 the output comes into the hidden layer of t-1, and of course it has some input layer which is shown by a small circle which is xt-1, but it's basically a mate. From each time instance, the output goes into the next time instance, basically the hidden layer of next time instance, and we multiply it of course by the weight of that time instance, and it has its own input at that time instance. So let's implement the first basic recurrent neural network in Pytorch. we name it a single RNN. Don't forget to inherit the nn.module. Give it a meaningful name, of course. At the first line, it's just like instantiating, creating any other simple neural network. We create a constructor. Here we have wx and wy. So this means that I have two time instances in this recurrent neural network, and I have the input as input size, which I can specify, and I have the number of neurons in each layer. I mean, here I have kept an option to make it a variable so that I can create a recurrent neural network of any size. So it's helpful, but be careful about the dimension of the matrix for the first set of weights. You have to keep it as input size comma neuron. For the last layer, you have to keep it as neuron comma neurons, and so on. So that's how it goes, as in input size goes like input size, then number of neurons in the next layer, then number of neurons in the previous layer, comma number of neurons in this layer, and that's how you can create more weight matrices for each time instance. And I am keeping the bias as 1 comma number of neurons I have, so it's same for each layer. Okay, now I'm declaring the forward pass. To declare the forward pass, you can see that in the first time instance, it's basically wx comma x plus b. To do the multiplication operation, I'm using torch.mm, and I'm adding the biases, which is just like a linear equation, and this tan h gives it non-linearity. Tan h is one of the very useful activation functions that are used in RNNs. I'll make a separate video where I'll explain all the activation functions, and I'll explain where each one of those are used. In the similar way, I'm declaring the forward pass for the next time instance. Let's say time instance 1, this was time instance 0, and as you can see here, the output is moved on to the next layer in the forward pass. So what I'm doing here is I'm calculating the weights of the second layer and multiplying it with the output of the first layer plus the inputs of this layer and previous layers weights. And finally, I add the bias as usual, you can guess. So this is like this thing, W, and this is like U. So after this, we shall have the outputs. Here I'm keeping the number of inputs as 2, as in I have 2 inputs. You need to understand how to give a neural network its inputs. So I have 4 rows and 2 columns. 4 rows stand for 4 features of the input, and I have 2 input. So this is one input and this one is another input. Same for the time instance 1. This is one input and this is another input. And each row is one feature. And when you run it, you will get the output for each time instance. Here I'm instantiating my single RNN class and here I'm getting the outputs from each time instance. So be careful about the dimensions of the matrices once again. And here is the outputs for the first time instance, 0th time instance. This is for the first time instance. That's how you implement a simple recurrent neural network in Pytorch. Thanks for watching.